Hey everyone, Morgan back at you, and today we're going to be talking about some mathematical examples from colligative properties. So our first question here involves a vapor pressure. It's a vapor pressure question, and it's a mixture of benzene and toluene, which form what is pretty close to an ideal solution. Okay, so what is the vapor pressure of this solution? If the mole fraction of benzene is 0.3, toluene it's 0.7, the vapor pressure of benzene is given, and the vapor pressure of toluene is given. So P total equals the pressure of the benzene plus the pressure of the toluene, which equals the mole fraction of benzene times the vapor pressure of pure benzene plus the mole fraction of toluene times the vapor pressure of pure toluene, which is equal to 0.30 times 73 torr, plus 0.70, remember mole fractions have to add up to 1, times 27 torr. And that equals about 41 torr if you round off for sig figs. Okay. Now, question about colligative properties. So we have the constants, freezing point and boiling point constants for water that are given. We have an ideal solution. Ideal. It's 0.050 molal sand, so it's not going to dissociate. What's the freezing point? Well, the change in the freezing point depression, is KFM, which equals 1.86 degrees Celsius kilogram per mole times 0.050 mole per kilogram. So kilogram cancels, mole cancels. And that equals 0.093 degrees Celsius. Now, normally, water freezes at 0 degrees. So I'm going to subtract that off of 0 degrees, and the freezing temperature is negative 0.093 degrees Celsius. Okay? Now, the boiling point, delta TB, equals KBM, which equals 0.513 degrees Celsius. I'm going to write it per molal this time, times 0.050 molal, and the molals cancel. And this equals 0.0257 degrees Celsius. A lot of sig figs I won't end up using. Now, the normal boiling point for water is 100 degrees. So I'm going to add this to 100 degrees and get 100.03 degrees Celsius. I'm just rounding that off. Okay. Now, we're going to look at what are some very useful examples of this when we're trying to do things like determine different molecular weights and identities of substances and the such. So, we prepare a solution, 18 grams of glucose in 150 grams of water. The boiling point is now 100.34. That means it went up by 0.34 degrees. I want to find the molecular weight. Well, I know that delta TB is equal to 0.34 degrees Celsius. So the molality equals delta TB over KB, which equals 0.34 degrees Celsius, okay, per molal, divided by 0.513, I'm sorry, that was just 0.34 degrees Celsius, my bad, over 0.513 degrees Celsius mole per kilogram, or per molal. Now the degrees Celsius is going to cancel, and this is 0.663 molal. Now I can take that number, 0.663 moles per kilogram, and multiply by the kilograms of solvent, which is 150 grams of water, or 0.150 kilograms. And that tells me I now have 0.0994 moles of the glucose. Well, I know originally that I had 18.00 grams of the glucose, and it corresponds to 0.0994 moles, and this equals a molar mass of 181 grams per mole. Okay? So this is how we can use it to identify molar masses, and you're going to have to do this on your next test. Okay, so I'm going to look at the other two questions here. I'd like you to kind of try these on your own. Come back, then check your answers. This time we're given percent compositions. Okay, so what I have done is found the empirical formula. That's a skill from back in about September. The empirical formula is CH3O. Then I've done the same thing that I did up here. Found a molar mass of 62. Now the molar mass of the empirical formula is 31, so it goes into 62 twice. And my molecular formula is C2H6O2. Leave that up there for about 5 more seconds. Pause if you need to. All right, now go try number 5 and come back when you're done. I'll count to 5. You can pause the camera. All right, so the empirical formula is S sub X. Do the same thing again, starting out by finding molality. Moles, grams per mole, gives a molar mass of 255, which means the X must be equal to 8. Okay, and that's a little bit about some mathematical problems for colligative properties. You will get a few of those in your homework and on your next test. Okay, thanks for tuning in. This is Morgan, signing off.